So in this video, we are going to be taking a look at constructions 6 and 7 together. And what we are going to be looking at is how can we divide a given line into any number of equal parts. Okay, so here we have our given line, and we'll just label the endpoints of this line A and B, like so. And what we want to do now is we are going to draw a line at any angle you so choose from A, moving up this direction. Okay? And then from B, we want to draw another line moving in the opposite direction, but this line must have the same angle as we put on the angle here at A. Okay? So the angle A, these two lines must have the same angle because we need these two lines to be parallel. So, having drawn those two lines, what we're going to do now is taking our compass and setting any width you so choose on it, we are going to draw as many circles along the line here at A as there are parts we wish to divide the line into. So for this example, we want to divide our line AB into 3 equal parts. So we'll draw 3 circles starting at the point A. So we'll draw the first one now. Okay, and the radius can be any radius you want, but whatever you set the compass at for this first circle, it will stay at that radius for all circles. Okay, now we want to mark where this circle intercepted this line here, point C, and around point C we will draw another circle, and it will have the same radius as the first circle we just drew. Okay, we will mark where this circle intercepted our line, point D, and we'll draw one more circle because we want to divide AB into 3 equal parts, so that's how many circles we will draw. So we'll draw that circle now. Okay, and we'll mark this point here. Okay, so having drawn those circles, keeping the compass the exact same, we will move to point B and draw a circle centered on the point B. Okay, again, same system we used up here. We'll mark where this circle intercepted our line here. Point F, we will draw a circle, same radius, centered around that point. Okay, again, we will mark this point of interception. Point G, draw a circle centered around that point. Okay, and finally, we'll mark that point of intersection H. Okay, so our construction is largely complete now. What we are going to do is we will join A to H, C to G, D to F, and E to B. Okay, so we just draw those lines with a ruler like so. Okay, and that is our construction complete. You can see we have divided the line AB into 3 equal parts, one part here and one part here. Okay, and that is how we divide that. So if we had 4 equal parts required, we would have drawn another circle here. We would have had 4 circles and so on. Okay, and we're just marking their points of intersection, and that's how we do it. So now we know how to do the construction. We want to see why this construction is valid. So the reason why we can say AB has been divided up into 3 equal parts or n equal parts is all to do with parallelograms. So we know that the length of the line segment AE is equal to the length of the line segment BH. And we know that by construction, because we made each of these circles of the same radius. So we have made the line segment AE to be equal to the length of the line segment BH. We also know that the line segment AE is parallel to the line segment BH. And again, we know this by construction because we made this angle here when we were starting out equal to this angle here. Okay? So, since BH and AE are parallel and congruent, or of equal length, that tells us that we have a parallelogram AEBH. Okay? Now, by similar argument, we can say that AC has the same length as GH. Also, AC is parallel to GH. And so, we have a parallelogram ACGH. And we can make similar arguments, and what we are showing is that AH is parallel to CG, which is parallel to DF, which is parallel to EB. Okay? And once we have established that, the rest of this proof follows from Theorem 11 of your Leaving Cert course, and that is one that says if three lines, or three parallel lines, cut off equal segments on some transversal line, then they will cut off equal segments on any other transversal line. And basically what that is saying is that if these parallel lines cut off equal segments on AE and BH, then they will cut off equal segments on any other line that transverses or goes through them. So we know A, C, CD and DE are equal to BF, FG and GH. So we have three equal divisions, and any other line cutting through those parallel lines will also be divided up into that many equal divisions. And that is why we can say this construction is valid.